Okay, let's take a look at some of the problem-solving strategies I used in solving problem number 2. So the first one, jumping around reading. You saw me doing this as I was going between looking at the graph and trying to interpret different pieces of the graph, and then going down and looking at the different answer choices, and then going to writing different things down in using algebraic notation, for example, and going back and forth between those three different kind of pieces of the problem as I was working on making sense of the problem. Number 2, solving a simpler problem. In particular, notice that I pointed out the difference between an equation and an inequality. And the graph in problem number 2 is clearly an inequality. However, I didn't really pay much attention to the fact that this was a problem about inequalities, because as it turned out, that wasn't really that critical. Just the fact that I was able to write down the algebraic form of just the graph of the straight line and kind of ignore the shaded part, the part that made it an inequality, that was really all I needed. And since it's typically simpler to come up with an equation of a straight line as opposed to figuring out, is this a greater than sign or less than sign or greater than or equal to sign, I just stuck with writing down as an equation, and it turned out that was all I needed. So I was able to solve a simpler problem and still get the correct solution. Strategy number 3, translating words into symbols. Again, this is something that is often done in trying to make sense of and solve math problems. And again, in this problem, we saw the use of the word is meaning equals, and we used that in this particular problem. And also, it turned out that for this particular problem, translating the words, the English words in the different answer choices, translating those into algebraic symbols, which made them into equations, it turned out that for this problem, that was actually a little bit easier than in some other types of problems, simply because the way the answer choices were phrased. It turned out really all we had to do was just about write down the different words, convert them into symbols as we go. So sometimes you get problems like that where on first glance it looks like the answer choices, in this case, they're fairly complicated, but then when you look at them a little more closely, that was fairly straightforward, that translating words into symbols part. Finally, the activating prior knowledge strategy, and in this case we activated prior knowledge that we had about linear functions, and in particular the y equals mx plus b form of a linear function, the slope-intercept form, which we used in order to come up with the algebraic expression of our straight line graph. We also used what we knew about positive slopes versus negative slopes. And the fact that we know that positive slopes go in this direction and negative slopes go in this direction, and that turned out to be particularly useful for this problem. So again, notice these are not the only possible strategies that you could use to solve this problem. You may have used some different ones, and if so, I encourage you to compare yours to the ones that I used, or possibly compare the ones I used to ones I've used in other problems. Also, compare them to the ones that maybe a classmate has used, and talk about the different types, the different advantages and possible disadvantages to the different types of strategies that you can use, because the more familiar you are with these different types of problem-solving strategies, the more you'll have to draw on if you become stuck when solving a particular problem.